first one. X squared plus 10x. Complete the square, then factor the trinomial. Okay?
Okay.
How do I complete the square here? It's a two-step process. Same thing every time. Take half of the coefficient of the x term and square it.
Okay.
And add it. So what's half the coefficient and squared?
It's half of it's 5, and then 5 times 5 is 25.
Okay, so I'm going to add 25. There's the trinomial they're talking about. Now how does that trinomial factor? And it always factors the same way. In other words, the whole reason we complete the square is so that we can represent that trinomial as a binomial squared. So what is it? X what?
5.
X plus 5. In other words, every time we complete the square, you're going to be able to represent it as x plus or minus whatever half of that was that you took to add to it. So in other words, we don't have to do factoring. We just have to remember what half of that coefficient was.
Okay.
Okay? So it's pretty simple and straightforward. And it's always the same rule. So here, complete this square.
It'd be
And you always add it.
it'd be plus 4.
And then how would I represent it?
X plus 2.
It's always going to be the same sign as that.
Oh, okay, minus 2.
Yeah, because that's the only way you can produce that middle term of minus 4x is if it's x minus 2. If it's x plus 2, this middle term would be a plus. So the sign you put here is always going to be the same as the sign there.
Okay.
Okay? And the third one, x squared plus 7x.
Wait, am I only doing it to the factor? Is that it?
Well, we're completing the square for this expression, and then we're going to represent it as x plus something squared.
Okay, so that's it.
It's just two steps always. It's taking half the coefficient, squaring that number, adding it, and then representing it as x plus whatever half that coefficient was. So I already know that I'm going to be able to do this without even completing the square. But we still have to complete the square.
I thought completing the square was like finding what x equals.
No. Completing the square is two steps. It's taking half the coefficient of the x term and squaring it and adding it to the expression.
Okay.
Okay? It's exactly that. So what is half of 7 squared? Now, you can do this on a calculator if you want, but let's just do this. Let's square half of 7 and add 49/4. So
I
there,
got 12.25.
you know what? I prefer 49/4. It actually makes it more understandable. And in fact, let's do this. Let's say 7/2 there. You see, in other words, I don't need a calculator to do this. I put a 2 under it to divide it in 2, and then I square the top and square the bottom. So you see what I did here? Okay. So now we'll go to the more useful. I don't particularly like those first 3 exercises because you can't just arbitrarily add numbers to expressions, whereas problem number 4 is an actual equation where I'm going to complete the square, but because I'm completing the square, I need to do whatever I do to the left side of the equation also to the right. So what do I have to add to the left in order to complete the square?
Nine.
Okay, that allows me to, and then I have to add 9 to the right also. Okay, now how can I represent this trinomial?
It would be x minus 3 squared
Right.
equals 36.
Okay, and now we can solve this. In other words, it was going to be difficult to solve. Well, it wouldn't necessarily be difficult to solve, but this will now be easy to solve. How do we solve this equation? What's the next step?
Finding square root.
Okay, so when I take the square root of the left side, I get this. What do I get when I take the square root of the right side?
6.
I'm going to make you wear a string on your finger saying plus or minus.
Okay.
Okay? So, and it's extremely important here because we're going to get 2 different answers. So x is equal to what?
Plus or minus 9.
Plus or minus 6 plus 3. That's not plus or minus 9. In 1x, where we use the plus value, gives us 9. But the x where we use the minus 6 value gives us minus 3. So those are the 2 answers that satisfy the equation. And you got to come up with both of them, and you would not do it if you didn't have that plus or minus. In other words, if we just had plus 6, then x would have been equal to 9, and we would not have found this other solution. So this is the exact pattern on every single problem where you complete the squares. You go through every single step exactly the same. So let's do another one. Number 5. X squared plus 12x plus 3 equals 1. Well, the one thing you're going to do when you complete the square is you want to set it up so that your variables are on one side and you have nothing but numbers on the other. So I'm going to start off by subtracting 3 from both sides. Now I have it looking much like number 4 looked. So now help me solve this by completing the square.
You do x squared plus 12x plus it?
No, we take half of this coefficient and square it. What's half of 12?
Oh, 6. So it'd be plus 36.
Okay. Can't add 36 to the left unless I add 36 to the right. Now, how can I represent this trinomial?
X plus 6 squared equals 34.
Okay. Next step.
The square root.
Okay, so tell me what the next line is.
X plus 6 equals
Don't think they want it in decimal. I think they want you to leave everything in radical, if I'm not mistaken, but I might be wrong, but that's the way it should be. Just leave it in radical form.
so 34 over.
No, square root of 34.
Oh, okay.
But it's plus or minus. So now what is x equal to?
X equals plus or minus the square root of 34 minus 6.
So give me both solutions for x.
I don't know the square root of 34.
No. By both solutions, I mean this is kind of a combined answer. If I want the specific two solutions, then I got to do one using the plus square root and the other using the minus square root. So in other words, plus square root of 34 minus 6 is one solution, minus square root of 34 minus 6 is the second solution. And I don't normally write the plus sign there. If you don't write the plus sign, it's implied. So you get it? See what we're doing every time?
Yeah.
Okay. Let's do a little harder one. Number 6. This time we have a 2 in front of the x squared term, so we have to worry about that because you can't complete the square unless you get that coefficient to be 1 to even begin. So what's the first step here?
Minus 10.
Yeah. There's actually an easier thing to do here, but I'm going to ignore it because they're trying to get you to complete the square here. Now what?
And then it'd be 2x squared plus 4x plus 4. Add 4 to both sides.
Not quite, because you cannot complete the square as long as this coefficient is not 1. Right now it's 2. So we have to turn it into a 1, and I do that by factoring out a 2 from the left side of the equation. Like that. In other words, I haven't done anything yet other than remove the 2 from the x squared term. And I was able to do that by factoring out the 2 from both of these terms. Now what?
Add 1 to the left side and add 2 to the right.
Very good. In other words, when I write the 1 in there to complete the square, I'm really adding 2 to the left. I'm not adding 1, I'm adding 2 because everything in the parentheses is being multiplied by 2. So now I have to add 2 to the right. So now I have what? I have 2 times What's in the parentheses?
X plus 1 squared
Okay.
equals 50.
Right. And now the next step is pretty standard. What's the next step?
Divided by 2?
Yep. And the next line?
The square root of both sides.
Would like you to read me the next line instead of saying that. Because I want to make sure it's not just taking the square root of both. That is what we're doing, but if you read me the line, I'll know whether you can do it on your own.
It'd be x plus 1 equals 5, plus or minus 5.
Okay. Better late than never. Okay. So x is equal to what? Now, at this point, rather than writing plus or minus 5 minus 1, let's go ahead and solve for both x's.
X equals 4 and x equals negative 6.
Very good. Okay, rewrite the equation in standard form and then solve the equation by graphing. Okay. X squared equals 6x minus 8. First of all, standard form is ax squared plus bx plus c equals 0. So how do I rewrite this in standard form? In other words, I want to make, yeah, exactly. Okay, go ahead. So what's the standard form? Give me the standard form.
It'd be 0 equals negative x squared plus 6x minus 8.
Okay, that actually is correct. But we would prefer if we have a positive coefficient in front of the x squared instead of a negative one.
So then divide by negative 1?
Yeah. Or instead, let's move the 6x to the left and the 8 to the left to begin with. In other words, when you're rearranging these terms to get it into standard form, recognize that we already have a positive sign in front of that. So let's move the other two terms over. Essentially the same thing as what you did, only maybe one less step. Because you moved the x squared to the right, but then you had to divide everything by minus 1. So, okay, so that's standard form. When they say solve the equation by graphing, what do they mean? What do they want from you?
To graph it or find
with your calculator?
I think they just want, no, because we don't really use graphing calculators when we on homework unless we do it at school.
Okay. So that's not the method they want you to use. So how do they want you to graph it? Because there's all kinds of ways. There's all kinds of ways to graph a function. You could make a table. No, you couldn't really. What do we have here? We have x squared minus 6x plus 8 equals 0. Well, we know that's a parabola. Where's its vertex? Let's do it this way. This may or may not be. I'm not sure exactly how they want you to graph this.
Yeah, they probably want us to find the vertex and then
Okay. All right. So what is the vertex line of symmetry? Or the vertex x coordinate?
negative b over 2a.
Which in this case is
Is 6 over 2, which equals 3.
now what is the y coordinate on the vertex?
Do you plug in 3 for x, or how do you find
exactly.
Okay, so hold on.
Okay.
What's 6 times 3?
Okay, so we got 9 for x squared minus 18, which is 6 times 3, plus
Plus
8.
8 equals 0.
What is that? Well, it's not equal to 0 anymore because we're solving for the y coordinate of the vertex. So we're no longer looking for an answer to this problem. In other words, we were given just this function here, and it's hard to explain, but I'll point it out as soon as we do it here. So what is 9 minus 18 plus 8?
-1.
Okay, so that's the y coordinate of the vertex. So the x coordinate is 3, the y coordinate is -1. So that's 3, -1. And we know it's going to look like a U, but in order to graph it, we need another point. Or actually, if we're trying to solve the equation by graphing it, we need to know where it crosses the x-axis. And that would be the solution. And the reason being, here, let me try to explain it. I know it looks something like that, but I don't immediately know what that point is, or that point, or this point. So I can't solve it until I know these 2 points. Because those 2 points, notice, that's where y is equal to 0. In other words, it's at these 2 x's that I've drawn here that are the most important points on this graph. More important than the vertex at this point. Because finding these 2 values solves the equation. Notice that this function is equal to 0. Well, these 2 x's, y is 0 there. That's why that's the solution to the equation. So, in order to solve for those, we can't really do it graphically. We have to factor this quadratic into x-intercept format. I'm a little puzzled by their instructions here.
Well, should we just find out what x equals?
Yeah, but you can't do it you can't do it graphically. You could with a graphing calculator, because then you could put your tracer and find out what that value is for x. But notice from the vertex alone, we can't figure out what the zeros are of this function. And the zeros meaning the x-intercepts. However, we can factor the equation. Let's go ahead and do that.
I got x minus 3 squared equals -8 for the factor.
What is it?
I got x minus 3.
How about x minus 4 and x minus 2?
Oh, because I thought we had to subtract the 8 and then find the half
You
of
have,
6.
you're close. We need factors of 8 that add to 6 because of this plus sign right there. That plus sign tells us we need factors of 8, two numbers that multiply to 8, that are going to add to the number 6. And that would be 4 and 2. And it's minus minus because of the minus sign in the middle. So this tells me my two zeros. What are they?
4 and 2.
Now I can graph it. I know this point is 4 comma 0, and this point over here is 2 comma 0. But notice what I had to do in order to graph it. I had to factor it first and then graph it. So to solve the equation by graphing doesn't really make any sense. We cannot solve that equation by graphing it. We can solve it by factoring it and figuring out what the solutions to it are. Maybe they want you to find the vertex like we did, which is all well and good. I have no problem with graphing the equation, but we can't adequately graph it. We can't really accurately graph it until we've solved it, until we've factored it. We have no way of knowing what those x values were before algebraically solving it. Let's do another one. And let's do every part of it. In other words, it's still useful for you to know what the vertex was, even though, yeah, I guess we had to find out the vertex in order to graph it anyway. Okay, so what's the first step here? We got to put it in standard form. What's the next line?
It'd be x squared plus x plus 3 equals 0.
Good. Let's find the vertex x coordinate.
It'd be negative 1 over 2.
And the vertex y coordinate. What's negative 1/2 squared?
One-fourth.
Good. That looks like it's 2 3/4.
Wait, wouldn't
Okay.
it be 1?
Did I do my math wrong? Let's see. This is 2/4. This is 2/4. So we have 1/4 minus 2/4, which is a negative 1/4, plus 3 is 2 3/4.
Wouldn't you put a 1 under the 3 and then add it so you would get 3 halves?
Well, here's what I do. Let me show you exactly. Okay, we're adding a negative 1/2. I want to add the 1/4, so I change it to 2/4, like that, because I'm looking for a common denominator. And yes, I suppose you could put a 1 under the 3, although it's not necessary. Let's first of all do this. What is that equal to? What's 1/4 plus a negative 2/4?
1.
Okay, you have the same denominator, so you can just operate on the numerators. What's 1 minus 2?
Negative 1.
Over 4 plus 3. So negative 1/4 plus 3 equals 2 3/4. I don't need to find a common denominator. I know how to add 3 and take away 1/4. In other words, negative 1/4 plus 3 is exactly the same as 3 minus 1/4. And if I take away 1/4 from 3, I got 2 3/4 left. Okay? All right, so we know how to graph the vertex, but we don't know how to graph the x-intercepts without solving this equation. So let's solve it by factoring, and then we'll be able to graph it. Why did they do this to you? Can't factor it. Maybe they really want you to use the quadratic formula? You've had the quadratic formula?
No solution problem.
No, this has a solution. Well, maybe it doesn't. B squared minus 4AC. You're right. This has no solution because of the quadratic. But you don't discover it until you try to solve it. Let's do it. So you've had this.
Yeah, I've had that, but it usually says if you have fractions or decimals, that's a no solution.
Well, that's not why we have no solution yet. We don't know we don't have solution. In other words, it might, just because you can't factor something with whole numbers, doesn't mean it doesn't have a positive solution. It would just be a decimal number. But the real key to finding out that this has no solution is examining what is called the discriminant, the b squared minus 4ac part of that. If b squared minus 4ac is a negative number, you're done. There's no solution. You're not quite done. We still have to graph it. Now I get it. Now I get it. All right. Let's go back to this point right here. Let's graph this based only on the vertex. Notice the vertex is at minus 1/2 plus 2 3/4, like that. We know the equation opens up based on the positive coefficient in front of the x squared term. So it's going to be a parabola that goes like that. Now, based on that graph, I can see that that parabola does not cross the x-axis. And because it does not cross the x-axis, there's no solution for this equation. In other words, there is no value of x that will make this equation equal 0. Because if there was, it would have to have some x-intercepts. So in this particular problem, by graphing it, I can see that there's no solution. I'm not sure exactly what they wanted you to do on number 7 because there's no way to graph that. You can find the vertex of it, but you can't find the x-intercepts by graphing it unless you solve the equation. Okay, so I kind of get why they're asking these 3 problems here. Let's do number 9 and see what it looks like. All right, so number 9, we got 5x minus 6 equal x squared. So what are we going to do here? What's standard format?
Subtract negative 5 plus 6.
Read me the next line.
0 equals x squared minus 5x plus 6.
Let's put the 0 and make sure it's usually on the right, like that. rather than starting off with the 0. Okay, what's the vertex x coordinate?
It'd be 5 over 1, so it'd equal
What's a?
5.
It's minus b over 2a.
Sorry. Yeah.
Okay. And then what's the y coordinate? So if we square this, what do we get? In a fraction?
What's 5 over 2 squared?
Well, square the numerator and square the denominator. What is it?
25 over 4.
That's the way to do it. Minus 5 times 5 halves plus 6. So let's do this. That's 25 fourths minus 25 halves plus 6. Now how do I handle this?
Do 25 over 4 minus 25 halves.
You can't subtract two fractions if they don't have the same denominator. So I need to find a common denominator between those two. What is it?
2,
No,
8.
it's 4. The common denominator is the lowest common. 8 is actually a common denominator, but it's not the lowest common denominator. The lowest common denominator is going to be the number that both of these divide into evenly. Notice that it can't be 2 because 4 does not divide into 2 evenly. 2 fourths is not even. It's not a whole number. But 4 is divisible by 4, and it's also divisible by 2. So our common denominator is going to be 4. So I don't need to change this one. About 25 halves. How many fourths is that? What do I have to do to the fraction to change the denominator to a 4?
Multiply by 2.
Multiply by 2 over 2. Not multiply by 2. If I multiply by 2, I'm going to change the value of that fraction. I don't want to change the value of it. I just want to change the denominator. So I can multiply a fraction by the number 1, which is 2 over 2. So that becomes 50 over 4 plus 6. Now I can deal with it. Now I can handle this because I got a common denominator. What's 25 fourths minus 50 fourths?
25 plus 6.
Negative 25 fourths plus 6. Remember, I'm subtracting a bigger number from a smaller number. Whenever you subtract a bigger number from a smaller number, your answer's got to be negative.
Okay.
If 7 minus 9 cannot be a positive number because 9 is bigger than 7. Okay? So what is minus 25 fourths plus 6 equal to? To do that, I can either change the 6 and give it a common denominator of 4. Let's do that. In other words, I need a common denominator to do this math. Common denominator is going to be 4 because both 1 and 4 divide into 4. So how many fourths is 6? What do I have to do to 6 over 1 in order to give it a denominator of 4? And remember, I can only multiply this by the number 1.
Multiply by 1/4?
No, I can only multiply it by the number 1. In other words, there's two situations. There's where you're solving an equation and you can do anything you want to the left side of the equation as long as you do it to the right side. And then there's the situation where you have a number or a fraction that you're merely trying to change the denominator. When I have a fraction, the only thing I can do to it is multiply it by 1. If I do anything else, I change its value. I don't want to change its value. I just want to change the way it's shown. So I'm going to multiply it by 4 over 4. And that's going to give me the denominator that I want of 4. Now I have minus 25 fourths plus 24 fourths. What's that equal to? Operate just on the numerators. Leave the denominator the same. What's minus 25 plus 24?
-1.
Okay. The only thing I would say to that is you need to get to where you're 100% sure of that answer every time, and you need to be able to do it quickly. And that is probably the thing that's slowing you down the most in math, believe it or not, is your hesitancy when it comes time to adding and subtracting negative and positive numbers. Until you can get fluent at that, these are going to be a lot tougher than they need to be. So we figured out that the y-coordinate of the vertex is negative 1/4. Okay, now let's graph it. So we'll put the x-coordinate at 5/2, which is 2.5. We'll call that point there 5/2, comma, negative 1/4. We know that the parabola goes up, and our solution are these 2 points right there. But in order to find out what those 2 points are, we have to factor this. So let's factor it. This one factors nicely. By nicely, I mean it produces whole numbers. What is it?
Wait, is 1/4 squared 1/8?
No, it's 1/16.
Oh, okay.
So we're factoring this quadratic. How do we factor it?
Plugging.
No. The very first thing we do is separate it into x and x, and then we examine that sign, which tells us that both of the signs have to be the same. So it's either plus plus or minus minus. Which is it in this case?
Minus minus?
Right, because this sign is minus. Now, because it's a plus, we're looking for two numbers that do what? Two factors of 6.
Multiply to 6 and add to 5.
Correct. What are they?
3 and 2.
Okay. So, what are our solutions? What are these 2 points down here? We've got the vertex labeled, but in order to solve the equation,
X equals positive 3 and X equals 2.
exactly. So now, after we've solved the equation, we can adequately graph it. That means this right point over here is at x equal 3. This left point is x equal 2. Notice that whenever x is 3, this equation is true. X squared minus 5x plus 6 is equal to 0 when x is 3. It's also equal to 0 when x is 2. That's why this parabola crosses the x-axis in those 2 spots.
Oh, okay.
Okay? All right, that finishes 1 through 9. Was there a second page here, or just was that the only one?
That's all I had.
That's all you had, okay. Okay. Well, that's fine to stop there. Here, let me just check whose appointment is next. I need to pull up my calendar here. Okay, let's see. You are scheduled for tomorrow night. Is Joel going to take that one? He sent me a text today saying he thought he was scheduled tonight and you were going to take his and he would take yours, but I don't know. Your mom made these. At this point, it looks like you have an appointment at 8 tomorrow night.
I'm not sure if it's me or my brother, but...
Okay, one or the other. I'll see one or the other of you tomorrow night, huh?
Okay.
Okay? All right,
Okay.
Marina. Have a good night. Bye-bye.
Thanks, you too.